Let's move on with the next item on our list. So on this survey plan, the next item we are going to work on is the scale. If I go back to the already finished site plan, this is the section I'm going to work on in this episode. So I'm going to work on the scale in representative fraction, the scale as a graphical scale or the bar scale, then the origin, and then the area. So basically, there are three ways of representing a scale on a map or a plan. We have the statement scale, is not here. We have the representative fraction, which is this one. Then we have the graphical or the bar scale, which is this one. So I'm going to show you the three when we switch to the AutoCAD environment. So, but before then, there is something I would like to point out before you start drawing or including your scales on your map or your plan. The first thing is for a scale, for you to determine the scale, you need to first of all figure out the paper size you want to use for your printout. So if you intend to print out this plan on an A4 size paper, then you need to choose a suitable scale for that A4 size paper. So I think that was the original decision that led to this scale 250. So this scale 250 was probably chosen based on the paper size A4. So if you intend to print your plan on a larger paper size, then you have to use the appropriate scale that fits to that size of paper. So let's go back to AutoCAD and then try to find out the best scale for the kind of paper we are planning to use. So in order to figure out that, you need to go to the print. You can press Ctrl P, or you look for the plot icon and click on it. So the shortcut is just press Ctrl P on your keyboard, and then you'll be taken to the plot model. So here you can select the printer you have on your machine. So here I'm selecting the default AutoCAD PDF printer. And what matters here is the paper size. So there are different kind of paper sizes, as you can see. So let's choose the A4 paper size. This is the A4 standard paper size. That is in landscape. Then the other option should be in the portrait. A4 paper size, this is it. So this is in landscape, while this is in portrait, as you can see from the preview on this panel. So when you make sure you select millimeters here, not inches, then center the plot, then what to plot, you select window, and then you click on the upper corner and then click at the bottom corner. Then let's go to the preview. So from the preview, you can see that it is perfectly fit to the center of the paper, but the paper is in landscape, so we need to switch it to portrait if that is what we want. So right click and then click on exit, then switch to portrait. If you cannot see this option, this portrait option, it is probably hidden and unique. You can bring it up by clicking on this arrow. So if this is what you are seeing, just click on this arrow to expand it, and then you see this option of the drawing orientation, and then you can select portrait. So select portrait and go back to preview. So when you click on preview, you see that this is exactly what we wanted. So if you go back to the plotter model, you can see under the plot scale, I chose fit to paper. So this is not what we want, because if you select fit to paper, it is going to use or the most perfectly fit scale to print your plan. But that is not what we want. So as you can see, the perfectly matching scale in this case is scale 1 is to 354, 354, or 355 approximately. But this is not what we want. So to make it scale 1 is to 250, you just remove this part and then add 250. So when you preview now, you'll see that the paper would have enlarged. So as you can see, this particular plan is larger than, or that particular scale is larger than what we are expecting. It's larger than the scale 1 is to 250. So if I switch back and then if I really want it to be fitted on the A4 paper, and then I need to use scale 1 is to 500. So 0.5 is equivalent to 1 is to 500. If I go back and preview, so you can now see that this is scale 1 is to 500. But 1 is to 500 is too small on this paper size, which is the A4 paper size that we chose here. So if I really want to maintain scale 1 is to 250, I just need to increase the paper size, because 1 is to 250 on A4, you can see it is cutting out virtually the whole plan. All the node arrow, the borderline, the title are not showing. So I just need to go back, exit, and then increase the paper size. So let me take it to A3 paper. So size A3. I will look for size A3. This is it. So A3 paper size is bigger than A4. So let's try that one. So this is A3. If I go back and then preview, yes, you can see that our plan now is fitting into the paper size based on scale 250. So if you must use a particular scale, first you need to determine the paper size. So it's the paper size that will control the kind of scale you use. So since we really want to make use of scale 1 is to 250, then it means we cannot use it on paper size A4. We need to increase the size of the paper to A3. But if you must use it, if you must use the A4 paper size, then it means you have to change the scale from 1 is to 250 to a scale that will fit into A4 paper size. So the rule of thumb is determine the paper size you want to use, then choose a scale that fits into that paper size. So that is how to determine the scale you are going to add on your plan. So another thing we need to talk about is to understand how scale are being represented on a plan. As you can see here, the scale is in millimeter, and then the equivalent unit on the ground, I'm representing it with 0.25 to represent scale 1 is to 250. And then another thing again is the unit will have the inches option. So the millimeter and then the inches. So these two are two different types of measurement. So we have two major types of measurement, namely the metric system of measurement and then the English or the imperial system of measurement. So the imperial is the one that you make use of miles, feet, inches, which is the second option here. So in this part of the world, we mostly work with the metric system of measurement. So I'm not going to talk about this in details. Instead, I'll focus on this one. So, but however, whatever is applicable here is also applicable to this. As long as you know the relationship between the systems. So, like here we have 1 mile is equivalent to 8 furlongs. 1 furlong is equivalent to 220 yards. 1 yard is equivalent to 3 feet. 1 foot is equivalent to 12 inches. So if you know this relationship, then you should be able to manipulate the scale in the imperial or the English system of measurement. So our focus in this video is going to be the metric system, since this is what we use in this part of the world. The plan we have here is going to be is in meters, is in meters, yes, and meters is related to millimeters as follow. So 1 centimeter is equivalent to 10 millimeter. 1 meter is equivalent to 100 centimeter, and then 1 kilometer is equivalent to 1000 meters. So if you know any of this, you should be able to find the other, as we are going to demonstrate very soon. So here, our unit for the metric system is in millimeter. So it means 1 millimeter will represent whatever unit on the ground. And then the unit on the ground we want to represent is in meters. So if you look at what we have here, 1 millimeter is set to 1 millimeter was set to 0.25 units. And then we said that this stands for the scale 1 ratio 250. So this part of the representative fractional scale is the unit on the map, and the unit on the map is in millimeter. While this part of the representative fractional scale represents the equivalent unit on the ground. So if you measure 1 millimeter on the map, it means you are going to measure the equivalent of 250 millimeter on the ground, on the earth surface. So this on the map is equivalent to this on the map. So let's see how we can go about the conversion. So since we know that our map is in meters, it means we need to convert the ground measurement to meters, not millimeters. So since we know that 1 meter is equals to 100 centimeter, and 1 centimeter is equals to 10 millimeter. So this is equivalent to 1 meter is equivalent to 1000 millimeter. Or you can even do the conversion from meters to millimeter, then from meters to centimeter, then from centimeter back to millimeter. So if this is in millimeter, what will be the equivalent in meters? That is what we are trying to achieve. So the equivalent will just be 250 divided by 1000. And then you can see the result is 0.5 meters. If I decide to do it from meters to centimeter, and then centimeter to millimeter, what I will do is, since 1 millimeter, 1 centimeter is this, then 250 millimeter will now be, in centimeter will now be divided by 10. So I'm going to have it as 250 divided by 10 to have it in centimeter. Then since 1 meter is equivalent to 100 centimeter, then 25 centimeter in meters will now be that 25 divided by 100. And then I still have the same 0.25 millimeter. So on the ground, if I measure 1 millimeter on the map, then on the ground I am measuring 0.25 meters. That is what the scale means. So if I go back to my AutoCAD, I can close this. Or before I even go back to the AutoCAD, I can rearrange this to tell you the type of scale these are. So this first one is what we call the uh, RF, representative fractional scale. And then the other type of scale we have is the statement scale, and it's equivalent to this. That is 1 millimeter represent 250 0.25 meters. 1 millimeter on the plan represents 0.25 meters on the ground. So this is the second type of scale. Then the third type of scale is the bar scale, or the graphical scale. So the graphical scale is what I'm going to talk about next, and it has to do with the drawing. You draw bars to represent the scale. So this is representative fraction. So these are the three type of scales that we use on survey plans. So the first, you type it the way it is. The second, you type it like in sentence format, just like this. Then the third one, you draw it. So I'm going to do this next. So let's go back to the AutoCAD environment to do that. So for me to do this, actually I'm going to create a new layer property. I'm going to do layer property and then create a new layer for the scale, so that we'll not have the mix-up we had earlier on in the previous episode, especially when we are trying to draw this stream feature on the plan. So here I'm going to click on this new button, and then I will rename the layer to scale. So I'm going to make the layer a current layer by double clicking, and then it will appear here as the current layer. So anything I add to the plan will be under this layer. If I want to switch, I can switch to different layer. So I'm using the scale layer, and then I want to draw the scale. So the first thing first I'm going to include on the layer is going to be the representative fractional scale, and then the statement scale. So let me include it just like this. So I'm going to add the text. So under the text, I'll copy the representative fractional scale, RF scale. I will just call it scale. Then I'll add it just like that. Then the second one is going to be the statement scale. So I'm going to reduce the English to 1 millimeter represents 0.25 meters. So if I wish, I can centralize it and click on OK. The font is too small, so I'll select it, go to the property panel on the right hand side here, and then increase the size of the text. So I'll increase the height of the text to maybe 2. If 2 is too large, reduce it to 1, or maybe 0.6. I think this is better. You can save, Control S, then Z, enter, E, enter to zoom to extend. So I think this particular text height is okay. Or I can make it 0.8 just to make it more legible. So this is it. So we have the fractional scale, the statement scale, and then we now need to add the graphical scale. The graphical scale is the most important one. And for you to draw a graphical scale, at least you need to have about two different sections of the scale. We have the primary section, and then we have the secondary section. So usually you draw a bar with 5 major subdivisions. The first being the primary scale, and then the second being the secondary. So to do that, I will simply go to my AutoCAD and then pick my line. Then I will make sure that the auto mode restriction is on so that I will achieve a perfectly horizontal line. So I'll click, then pull in this direction to maybe, let's say, let me just pull it up to this point. Then click and then terminate the line. Then the next I need to draw is the vertical line, a small vertical line. Pick L for line. Then make sure my O snap is on so that I can snap to the tip of the line. Then I can off it. Then I will go vertically downwards, maybe up to this point, just to a reasonable size that the scale will be represented. So maybe somewhere here. I think somewhere here is okay for the first division. Maybe somewhere here is okay for the first division. So I'll click, then I'll terminate the line, and I'll zoom to extent. Okay, I think the line is too short. So let me extend it. So I'm going to type N for line, enter, then I'll click somewhere here, terminate the line, then use the extend tool to extend to that line. Then I can now delete this, select it, and then click on erase, or click delete, press the delete button on your keyboard. So now that I have this, I can now offset. Let me use the offset command. Or before I use offset, I can use the measure tool to measure the distance that I'm going to offset. Maybe from here to maybe somewhere here. The distance is about 1.2 meters. So I'll use the offset command, offset. Then I'll offset to 1.2. I'm going to offset this line to 1.2. So select. Okay. No, this is wrong. 1.2. If I divide 1.2 by 2, that's the total length of the line. 1.2 divided by 2, I should have 1.6. So I'm supposed to offset to 0.6, sorry, not 1.6, 0.6. So I'm going to offset to 0.6 so that I'll have the line perfectly at the middle of the two lines. So if I zoom to extent, now I have something reasonable that at least I can work with. Let me move this to the very end using the O snap. N for move, then click at the tip here and then move it. So this is the graphical scale coming into shape. The next thing I would like to do is to partition the bar into 5 different sections. The first section will be the primary section, which is just 1 bar, and then the remaining 4 will be the secondary section. So to do that, I need to, let me use my measure tool. Then I need to measure probably from this edge. Let me on my O snap. I'm going to measure from this tip, from here. I'll measure in this direction. I'll measure in this direction. The total length is 70 point something, but I will not use up to that. I think what I probably need is since the scale is 1:250, I will most likely make the partition in 50s. So I will use the offset tool. So you type offset or you click on the offset command. Then you type in 50. You click on offset. Then I will need to offset in this direction after offing the O snap. I'm going to offset in this direction 50. So this is 50 total in length. So I can now trim off this excess part. So I will use the trim command. I will type in trim, or I will just pick the trim tool, then cut off this excess part, and then we can delete this. So the total length of this scale bar is 50 meters. So 50 meters, we need to partition it into 5, where the first one will be the primary part of the scale, and then the remaining 4 will be the secondary part of the scale. So in order to partition this into 5, I will use my calculator to find what the partition is going to be. So 50 divided by 5 is going to give us 10. So it means I will need to offset this into 10 meters. So offset 10 meters. So starting from this point, offset 10 meters. We'll have the primary part, then the remaining are going to be the secondary part. So offset 10 meters. Offset another one, 10 meters. And that will be the last one. So I have 1, 2, 3, 4, which are the secondary part, and then the primary part is the last one, or the first one. So before I continue, I would like to centralize this, the text representing the scale, and then the graphical scale. So I'll click somewhere in the middle and then move it to the middle of the scale bar. So remember, I'll have 5 partitions. This is 1, 2, 1, 2. So from the left we have 1, 2, from the right we have 1, 2. So it means the center is going to be somewhere here. So I'll click somewhere here in the center. Then I'll select everything and then move it to the center of the entire plan. So I'll click somewhere in the center and then I'll move it to somewhere here, which is believed to be the middle of the entire plan, somewhere here. Now I will move this north arrow downwards a little. So M for move and then move downward a little. So let me zoom to extent, zoom to this portion. So our scale is coming to shape. Next, we need to partition this. This section is the primary section. We need to partition it into 5 or 10, depending on how we want it to be. But I think we can partition this, since this is 10, we can partition 10 by 2. So we can have 5 subdivisions here. So I'm going to go to offset, type in offset, and then the offset distance is going to be 2 meters. Then I'll now click. I have one, I have another one, I have another one. So this is it. We have 1, 2, 3, 4, 5. We have 5 partitions for the primary section of the scale. So since I'm going to add the text on the scale bar, so I'll select only the scale bar and move it down a little. So I'm going to on my orthogonal mode on, so that I'll move it vertically downward. So M for move, then click and then move it downward a little. So this is it. Then now I'm going to make a copy of this. So I'll select it and then hit the copy command. Or I can just type in _ copy to copy this text and then bring it copy to this side, and then off my auto mode. Then I'm going to change this to, or change the text to 0. Then I'm going to select it and then move it downward. So I'm going to move it to this point. So if I'm satisfied with the position, then I'll on my auto mode to restrict my cursor movement in the vertical and horizontal direction. Then I'll copy the text, click on it, I'll copy it to this point, then copy to this point, and then when I'm done, I'll change the text later on. So I'm copying zeros now, copy here, then copy here. So I will now change the text. So from here to here is 10. So this is going to be the starting point, which is 0. This is going to be 10 on the primary side, primary part of the scale, so 10 meters. Then the next partition on the secondary side is 10 meters. So double click to change the text. So I'll just type in 10. Then go to the next one, double click on it to change the text. So the next will be 20. Then double click on it to change the next one. The next will be 30. Then double click on the last one, which is going to be 40. So this is going to be 40 meters. So when you use your measure tool, you'll find out that each partition is actually 20 meters from the, it's actually 10 meters from the next one. So from here, for example, to here should be 10 meters, as you can see. This is 10 meters. So the next thing we will do is to fill in these partitions we did in the zigzag format. So if I go back here, all I will do is to use the hash and then choose the hash pattern, solid in this case, and then I'll start from the first box in alternating a pattern. I'll click to hash each of the boxes, just like this. Next will be this, the next one will be this, then the next one will be this. So that is it. So our scale is now complete. So if you look at what we have here and what I just drew, they are two different distances. So here I decided to make use of 50 as my length of the entire scale. So while here I made use of 25 as the length of the entire scale. And that is why you can see that the secondary partition ends at 20 meters, while here the secondary partition ends on 40 meters, because this is the total length of this scale is 50, while the total length of this scale is 25 meters. So just take note of the difference. If I decide to make it 100, the value here will change because of the total length of the scale. So this is 50 meters length scale bar, while this is 25 meters length scale bar. As you can see from the size, this is shorter than what I just used. So what matters most is that you have added the correct distance on the scale bar, and then when the plan is printed on the paper, you can use either a rope to measure the graphical scale and then measure the equivalent distance on on the plan. So as you can see, if the total length of this scale bar is 50 meters, then just look at our plan. This is 38 meters. From here, from point 2 to point 3 is 38 meters. Then compare the ratio of 38 meters to 50 meters. So that means the whole of this will probably start from here and then maybe end somewhere here. This is 10, 20, 30, then 38 will end up somewhere here. Or if you're starting from the zero part of the secondary part of the scale, then the 38 will end up somewhere here. I can even demonstrate it for you. So I can pick or select from point 2 to point 3, which is 38 meters in length. Then copy it and then take it closer to the scale. Then I'll select it and then rotate it. RO for rotate. And then move it close to the scale and then try to measure it. So if you look at, if I place it somewhere here, close to the zero starting of the line, you see that this is at the length of 38. So it stops somewhere here. So what I did is to copy this line, which is 38 meters in length, and then place it here. And then you can see that this is almost getting to 40. It stops at 38. So I can delete it. So the usefulness of this is that when you print it on the paper, I can use a rope or whatever tool I have or whatever measuring tool I have in the physical world, scale it on the scale and then measure, take measurements on the plan or mark out measurement on the plan using this particular scale. So the graphical scale have disadvantage that when you shrink the map, the graphical scale shrinks together with the map, so it doesn't affect the scale. But in the case of representative fraction or the statement scale, when you shrink the map, it means the scale will now become invalid. But the graphical scale becomes invalid. It doesn't invalidate the graphical scale if you shrink or expand the map. So if you expand the map or the plan, the graphical scale will expand together with the plan. And if you shrink it, it will shrink together with the map. So and then you can use a rope or a ruler to measure the graphical scale and then establish distances on the plan. So that is the advantage of the graphical scale. So I think the remaining part of the scale should just be this. And these are just normal text that we can add. The first is the origin. So the origin, the location of the site plan is in Nigeria and then in Nasarawa State, as you can see from the title. And the Nasarawa State is located within UTM zone 32 degrees north. So then the area we need to measure the area. And then I'm going to show you that in a moment. So first of all, I will copy this. I'll copy it down using the auto mode on so that it will be perfectly vertical. I'll place it here, then double click on it to change the text. So the first is the origin. The origin is UTM, that's Universal Traverse Marketer, which is on zone 32 degrees. To write degrees, you type in %D. %D will give you degrees in AutoCAD. So zone 32 degrees north. Then the next is the area. So the area, I'm going to determine it in a moment. So let's measure the area of the plan. So in order to measure the area, there are several ways of doing it. But one easy way is to use the area command. So you can type in area or just select the utility tool and then select area. Then make sure you have the O snap on and you have the intersection or the endpoint ticked. So with that, you can now click around the boundary of the plan. So I click on point 1 then click on point 2, then click on point 3, then click on point 4. When you are done, you can now press enter to calculate the area. So the area is given as 475.137, which you can copy and then update the text. So the area is in square meters. So I can paste it here, and then this value is in square meters. Then the equivalent of this value in hectares. As you can see here, we have the value in hectares, both in square meters and in hectares. So to calculate the equivalent value in hectares, what you need to do is you use your calculator, and the relationship is just 10,000. So 1 hectare is equivalent to 10,000 square meter. So to find the equivalent of this value in hectares, you divide this by 10,000 by 10,000. So I can use the calculator from my computer or use the calculator made available in AutoCAD. But let's use this for the moment. I'm going to show you how to open up the calculator in AutoCAD and make use of it too. So this is 475.137, then divided by 10,000. 1, 2, 3. And then you have the area in hectares as 0.048 approximately. So in hectares, I'm going to put it in bracket or in braces as 0.0448. Let me approximate it to 48. Then HE for hectares. So this is the equivalent value in hectares. And if you compare it with what we have here, we have slight variation. This is because, especially in the square meter part, here we have 475.146, but here we have 475.137. So it's because of how I measured it using the tool. So another way we could have measured this is to convert this shape to a boundary. Just by doing this, I can BO for boundary, and then I will now pick a point to convert to boundary. I'll click inside this boundary and then convert it to a boundary. So if I point my mouse on it, you see that I have a closed shape, which is a boundary. Then if I go back to pick my area, if I pick my measure area tool, I can simply use this option. So instead of clicking around, I will just select object, and then I'll select the object, which is now a boundary shape, and then it will give me the area automatically. So you can see the area is giving us 475.137, which is similar to what we got earlier. So that is another way of getting the area. Then if you want to use the calculator made available in AutoCAD, you simply type in calculator, and then the calculator will come up. Open it up, and then you can make your calculations. So 475.137 divided by 10,000. 1, 2, 3, 4. Then equals to, and then you have the result. So this is how to make use of the calculator in AutoCAD. So with this, we have come to the end of this section, and then I hope you enjoyed it. And if you have any question, feel free to reach out to me. Thank you, and see you in the next episode. Have a nice day.